Today's lesson is determining if two polygons are similar. A map is an example of a drawing that is a reduced image of the original. Most maps indicate a scale, which is a factor used to reduce the size of the original. Therefore, a correct map is an example of a perfect scale diagram. A scale factor is written in the following form. Scale diagram to original, so we could write it 3 to 2 with a colon between, or scale over original as a fraction. This means when you are asked to determine what scale factor was used to create a second figure, you need to compare the new figure to the old figure. It's important to remember when a figure is enlarged, the scale factor will be greater than 1, as the new figure will have longer side lengths. When a figure is reduced, the scale factor will be less than 1, but greater than 0. You won't be having a scale factor of a negative number, and that will give you smaller side lengths. So if we look at the following scale factors, 2, 0.75, and 3.4, 2 and 3.4 would be enlargements. So if I had a side that was 3, and I was going to multiply it by a scale factor of 2, my new side length would be 6 centimeters. 0.7 would cause a reduction. So if my original side length was 1 and I multiplied it by 0.75, my new side length would be 0.75 centimeters, which is smaller than the original that I started with. Okay, like a scale on a map, a scale factor can be used to reduce or enlarge any figure. It is the number you multiply each side length by to create a similar figure. So I want to take this Canadian flag and reduce it by a size of 0.75. So I would take the length, multiply it by the scale factor to get a new length of 3.75 feet. I would take the original width, multiply it by the scale factor, and get a new width of 1.5. Quinn is making a diamond logo for an electronics store. When the logo appears on a business card, the two line segments composing the top measure 21 millimeters, and the line segments composing the bottom are 26 millimeters. The logo must be made 1/3 larger when it appears on the website and 2/3 larger when it appears on the flyers. Quinn must calculate how big the logos will be. Approximately what size will the logos on the website and the flyers be? So we're going to look at the website. The original is 21 millimeters. Now, we're going to take 21 times 1/3. Now, normally when you take 1/3, you're making a reduction, but it wants to be 1/3 larger. So we multiply it by 1/3. You find out that's 7 millimeters. Well, what you're going to do is take the 7 millimeters and add it back on to the original size, which is 28 millimeters. Okay, the second step is the second dimension, which is 26 millimeters. We're going to take that and multiply it by 1/3 and get 8.67 millimeters. So 8.67 millimeters plus 26 will give me 34.67 millimeters. Okay, for the flyers, we're going to do the same idea, but now it's multiplied by 2/3 bigger. So remember when you're multiplying that you multiply straight across, 21 times 2 and 1 times 3 to get 42 over 3, which is 14. Take the 14 and add it back to the original length, and our new dimension will be 23 millimeters. The second dimension is 26 millimeters times by 2/3 will be 17.33. Add that back on to the original 26 millimeters, and our new dimension will be 43.33. So the flyer dimension for the logo will be 35 by 43.33. Okay, we're going to take a look at a map and scale factors. This map has a scale of 1 centimeter equals 2.5 kilometers, and that's often shown the bottom right corner of a map. So we're going to use that information to solve some problems. On the map, Wall Street has a length of 14 centimeters. Using the scale, what would be the length of the actual street? So we write down the scale factor, 1 centimeter equals, or over 2.5 kilometers. We have a length of 14 centimeters, so 14 needs to go on the top because the centimeters are both on the top, and we want to figure out how many kilometers that's going to be. So we cross multiply and we find out that x equals 35 kilometers. The second question tells you how long Mattapan Street is. It's 25 kilometers long. So how long is the length on the map? This time, same conversion factor, 1 centimeter equals 2.5 kilometers. But this time, because we know the kilometers, it goes on the bottom and x goes on the top. We're trying to find out the amount of centimeters that would be on the map. When we cross multiply, we find out that x equals 10. You have probably seen maps that are not properly scale drawn. What are the purpose of these maps, and what advantage did the map makers get by distorting the scale? Well, there's a couple of different reasons. One is if you're sketching out directions for a map just to give to your buddy to get out to your house on an acreage, you may not do it to scale. You're just giving the directions and the gist of the idea of which direction he's going. The other thing that map makers do is, say, an insert for a city. They might blow that part out of proportion and put it on the corner of the map so you can see it in much greater detail. Lots of cities have one-way streets downtown, or special name streets, so they want to show those in the details. Okay, Ricardo was given the poster on the left and asked by his employer to reduce the poster by a factor of a half. Ricardo figured out the size of the news poster and drew the rectangle on the right. Do you think he interpreted the instructions correctly? Well, if he took 55 and multiplied it by a half, he would get 27.5 for the new length. And if he took 41 and times it by a half, he would get a new length of 20.5. So yes, he interpreted correctly. What did you notice about the surface area? Well, surface area is length times width. So 41 times 55 will give me a surface area of 2,255 centimeters squared. The surface area of this one is 27.5. By 20.5 will give us 563.7. If we take the surface area and divide scale surface area by the original surface area, we get a scale factor of 1/4. Well, that's not the same as the 1/2 that we started with, and we wonder how come. Well, if you take the surface area, its length is changed by a half, and width was changed by a half, then we actually change the surface area by 1/4. Do you think there could be more interpretations of what the employer asked? Well, you could have maybe made the length a half, but the width the same. You could have made the width by half and the length the same. So you could have done different things. So we have to be very careful when we are talking about similar diagrams to be very specific. Okay, example 1. If 1 inch represents 10 feet, what dimensions would you use to make a scale diagram of a building that's 20 by 40? So we're going to do each one separately. 1 inch equals 1 foot, which is our scale factor. The 20 feet is going to go on the bottom. When you cross multiply, you will get an answer of 2 inches. Okay? The dimensions, the inches, are on the top. Same thing on the right. The length, we take the scale factor of 1 to 10. We don't know the number of inches, but we do know that it's 40 feet. So when you cross multiply, you get 10x equals 40 and solve to find out x is 4 inches. So 40 feet would be drawn as 4 inches. These two octagonal windows are similar. Determine the scale factor used to create the larger window. So the scale is here because it's the one we're looking for parts on. The original is here. So to find the scale factor, we always put scale over original, so 20 over 13, and their scale factor is 1.54. So the scale factor is 1.54. Okay, to find out the new diagonal length, we take 34 times by the scale factor, 1.54, and we get 52.3 centimeters. Okay, a second way to do this is we could just use ratios. 20 to 13 equals x over 34. When I cross multiply, I get 13x equals 680. Divide by 13, and x will equal 52.3. So you should get the same answer. It doesn't matter which way you calculate it. All right, assignment, build your skills. These questions are actually attached to your notes. So there's a question about a skating outfit making it smaller pattern, and then the answer is attached on the next slide. There's a second question about an interior design making parallelogram stencils, and some questions, and the answers are attached there as well.